We start talking about relational databases next week, but let's start talking about databases today. Okay? The purpose of ERP is not always just to tie all functional areas of business together, it's to collect data. And to collect data in a fashion that is actually usable and valid and reliable, right? So we want consistent, reliable, valid data. And how do we get that? We have a database, and we store everything in the same exact way to get the consistency. Consistent means that everything's stored consistently, right? Like if I have first name as a field, it's going to be first name no matter who I get. But if somehow I accidentally put F name at some point and I start storing everything as F name, all the old records are still there. Under first name, now I have all kinds of inconsistency in data when I start adding things and all that good stuff. You follow me?
Yeah.
Okay. Can I get an amen? So, naming conventions. And that's what was happening if you had multiple tables or multiple databases that were separated. So they were not, they weren't relational, they were all separate. So you could have a table in a database that was first name like this, or you could have another one that was first name like this. And now what's happening is today people are paying students and interns money to rectify that, so you get a list of all the people that are first name, and you'll have to add them to the list that has the new field name. Okay? Not fun. Not a fun job at all if you don't want to do it. People get decent money, but it's a mundane task, right? You can write scripts that automatically do that, like through Python and that. You can write scripts that find everyone that's first name and automatically take and replace those, etc. So you can merge data that way. And there are people that make money doing that. And there's endless supply of jobs doing it, because here's the problem. We have been collecting data forever, and I think I've said this already, like Best Buy, for instance, would keep track of every piece of data that they thought might ever be useful. Sears did the same thing. So they had all these data warehouses full of information, or of potential information, right? Because we didn't have the power to analyze it all. And as the power increased, we start saying, hey, okay, let's start looking at this data. So I need 2 erasers. We have, just like in any other research, you look at statistics or whatever, you have consistent, you have reliable, you have valid, and or validity. Valid data, does it actually serve a purpose? You know, data that I collected 30 years ago, some of it might, but a lot of it no longer has any pertinence whatsoever. So that's kind of invalid, right? There's no purpose to it. Everything might have been consistent in your data and stuff, but it doesn't mean, oh, I also forgot accurate. But, which has to do with consistency, but yeah, it might not even be valid anymore. Why are we going to analyze data that's no longer valid? Makes no sense, right? So we have a lot of data out there that we're doing nothing with. So not only do we have people that can recode things and stuff like that, but we also have people cleaning data, getting rid of things that are certain age and stuff because it's no longer valid. Accurate has to do with the fact that if I spell your name wrong and I have you stored multiple times, etc., well, that's part of cleaning data. That's part of consistency and stuff like that. It's not just, this is, you have data entry, and then you have stored, right? So you have the way it was entered, and then how it's currently stored, and if you have an inconsistency in storage, and I have 5 records of you, how do I tie those together? And I have people that do that. That's part of cleaning the data. But we can't always do that. We can't always get it right because there's no guarantee that, your name again?
Drew.
Drew, okay. There's no guarantee that Drew, you're the same Drew that lived in Saginaw that now lives in Mount Pleasant. I can't prove it. So which record do I keep? So now I don't just look at name, I add your last name in the search. Okay, well now I've got 2 things that show that it should be you. Is that good enough? Probably not. So then I look at your email address. So I can add multiple layers and try to prove something's true. If it's not, then I have to leave it separated, even though it could be true. Right? Now, reliable data, that means that we get like results every time we test it. So I decide that I'm going to say, hey, I want to know all Northwood students that feel that AR-15 should be illegal. So I do a study. And I base it off of a sample of just this classroom. That is accurate. It's valid. It's current. I have a reason for it, right? As long as I do it and use like your student number as an identification, because it's something that will never change as long as you're a student here, or even after being a student here. We'll talk about that in a second. Is it valid? Yeah, we just said it's valid. Is it reliable? We don't know until we do it again and again and again. If I do it again and get totally different result, like totally polar opposites, that might not be very reliable. So I have to test again and see if I get any reliability and so on. So reliability comes over a period of time with multiple tests. Make sense? So this is why we do things, and we talk about how we're going to remain consistent and reliable and everything. At the end of the day, these are the most important things. Am I keeping my data accurate? Am I consistent on naming things and stuff of that nature? Well, relational databases allow me to do that. Okay? And you can take a database class and you can go into all this stuff and you can spend a whole semester learning what I'm about to teach you in 15 minutes. Okay? And I teach that whole semester class. We just do more. We get into the SQL statements and everything else. But as far as your relational databases go, it's all up here. So I no longer do the steps necessary to do it. There are normalizations. And remember how I said we recode stuff and all that stuff? Normalization of data is to make sure I get rid of redundant information like 5 of your records. So how do I make sure that doesn't happen? I'm having an asthma issue right now. I want to show you there are so many different normal forms. That's second, that's third, that's beyond third normal form. And they don't talk about it much beyond third normal form because third normal form is where most people stop. But there is, God, I can't remember, it's boycott or boycott. level of normalization, which happens after 3. It should be normalization level 4, but they called it something different. Then there's normalization level blah, blah, blah. And I think it goes out as far as 15 or something levels. Might be like, oh, got it, whatever. Let's see if they tell me here. Yeah, see, BC. I'm looking because I want to see the exact number because I want you to have an understanding. Most people don't go past, and that's the problem, so they don't talk about it. But in a textbook, they explain all the others, and yeah, we can't get people to talk about anything beyond that. There's something like between 12 and 15 different levels of normalization. And each level of normalization tries to get rid of more and more duplication. Now the problem exists that as you go through, and the reason that people stop at 3rd or 4th level is because as you continue doing it, you have a likelihood that you're going to create duplication because you're trying to get rid of it. So it can have a reverse effect. So people stop at like 3rd, 4th normal form. And 4th normal form is B, C, and F, which I can't remember what it stands for, why. It's a guy's name. That's 3rd, let's go down here, 4th. Boy Scout, there we go. Okay. So anyway, and if you look, they call it 3.5 normal form. Doesn't matter, there's just an extra step that you take. I skip all that because I just naturally think that way now. I don't make people do it. I just need you to understand that there are levels. Okay? And the reason is because it doesn't take much to get to their normal form. So what happens is this. Yes, I am jumping forward next week, just so you know. We have entities and attributes. That's what tables are made up of. Every table is an entity and it represents an entity. You as an individual are an entity, right? You're a person, you're a student, you're something, right? So, if I wanted to, I could create a table called student. And the old way of doing things, I would put everything that had to do with the student in there, your grades, your semesters, everything in one single table. So I would have the attributes. All possible things that could define the student at Northwood. You know, how can I find you? Blah, 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 all right? That would be first normal form. All potential fields for Northwood. Second normal form, we start breaking it up and we identify the main entities. And the main entities being like student, faculty, stuff like that that's separated. And then once we get those broken up, how do we connect them, right? Because the goal is to get rid of redundancy, right? By the way, that's a key word. Don't forget redundancy. Part of your consistency and accuracy is get rid of redundancy. If you don't know what redundancy is, I will put it in abbreviation. Okay. Not abbreviation, another word for it. So, attributes, everything that describes an entity. Okay. So, student has a first name, a last name. By the way, never just store it as this and have like we can work with it because I can create a program that automatically separates it based on space and all that stuff. It can create errors though, because what if you did? What if I wrote a program that recognized first and last name only, and somebody was a smart ass and put their middle initial in there? Creates a problem? Okay. So, biggest problem for anyone remote. Oh, shoot. I can't. This class is hard to do remote because I have to write on the board. So, bear with me. I'm recording this lecture for someone. So, anyway, anything and everything about you, address, city, state, zip, number, phone numbers, all that good stuff, the amount of money you owe, et cetera, et cetera, et cetera, everything that has to do with the student. This is valuable. We do need to store the data, but we need to do it in a way that is non-repetitive. We want to get rid of that redundancy. And it's really easy to do redundancy in this because I would have to, if I store it that way, every semester I have to create the whole record for you again, and you again, and you again. I don't want to do that. So, second normal form, we break it down into multiple things, which I'm already there. I started breaking it down. We have student, we have class, and so on, right? So we might have class name, class number. So, you know, you have like MIS, and then here you have 13250 or whatever as an example. So we'll have to show the example of what the data looks like so we can describe the data and create a dictionary of whatever field is, et cetera, et cetera, et cetera, right? So anyway, how do I get that to connect? There is, yes?
Would you use like an ID number for them, and then you could have it intertied with both of them?
I like you until now. Yes, that's exactly what you do, right? So what we have is a unique identifier. So, and we assign that to you, and will never get used again. I give you a student number. That's yours for the rest of your life. I can't use it again because it can create inconsistencies and problems in my data, right? I should say, you could, if you did an archive and that archive was by year, then you might be able to reuse it because then I, have a new year, new student. Creates difficulties though when you're searching for records and stuff like that. So we have a unique ID. In Microsoft Access and other areas, you have a primary key. And you have, or it might just be considered a key identifier or whatever. But primary key and unique ID are most commonly used. Okay. So for student, I give you a student ID. We're jumping right to third normal form right now. If I have grades, tie them together and create a relationship between them. So at this point, one student can have an infinite number of, I shouldn't move that way, it came down like this. Should be able to have many or an infinite number of grades associated with them. One class should be able to have an infinite number of grades associated with it, because otherwise I can only give one grade per class and maybe I give it to you or maybe I give it to you, right? There's no way of actually tracking where that went. The relational database model allows me to put your information in once and then all your related information. Do you want to see it work? She's like, I don't care. Yeah. Okay. She said, yeah, you guys are up. Sorry. You were like, we just want to leave. So anyway, I'm going to pull up Microsoft Access and show you this in its simplest form, because you are all so excited. Hello? Anyway, so I want to create a blank database, that's fine. And I have a table, and I'm going to change to design view because it will be more familiar. This looks like Excel when it's in this view. This is data sheet view. I don't want data sheet view. It doesn't look right. I'm going to create a student table, right? I'm going to change this to student ID. I'm going to leave it as an auto number so it automatically just numbers 1, 2, 3, 4, 5. If I was writing a program, I could randomize it and make it however I want, where maybe it has your first 6 initials, then a number, plus a character, or whatever I wanted, right? And then we have first name. That's text, I don't care, last name. Then you have address.
You're doing that to data type.
Then you have city, you have state, you have zip code. Now remember how I said we wanted accuracy? One nice thing about database is you can dictate how data has to be entered. So for state, I can make that 2 characters. I can format it so it shows uppercase always and stores it as uppercase, and I can tell it that it has to be 2 letters. So I create an input mask controlling how you input the data, right? Controlling how it can be stored. That's consistency and accuracy. You can't do anything else. Oh, wait a minute. We'll get to that too, because maybe I can do something else. Could I potentially use 2 characters that aren't representative of the state? Yeah. So I can do, instead of short text, I could actually set it up as a lookup list where I type in the values that I want and I type in all 50 states. Right? And then you would have to select from that, so I can control that. Or I can control that at the level of my programming. And then I could control it that if you type MI, it recognizes Michigan. If you type Michigan, it automatically changes it to MI for my database for accuracy and consistency. Okay? I'm not going to do that. I was just pointing out that you can still have errors. Zip code is not numerical as far as what we need. We could say that it's 5 plus 4 plus 1, 10. And the reason is because we can have, even though I'm storing it as short text because I'm not doing math with it, 4. I can set an input mask that you can only put numbers in. And if I'm saying that you have to have the dash 4 digits, you have to put it in. Okay? And sometimes that dash, the 4 digits, matches the street address or whatever that you're on, like the number, your street number. Sometimes it doesn't. So, city, state, zip. And then we have phone number. But phone number, you don't necessarily want to store it as a single value, right? You want area code separate because it makes it easier to find data. And again, that's short text. That's going to be 5 characters because I want to include the parentheses. So I'm controlling how people enter data. That's a nice thing about databases. I can have control and I can make it so you can only enter things a certain way, etc. You get the idea. You okay over there? You're yawning. I'm boring you. That means I'm doing my job. Okay, so, and I can keep going and going and going of all the things that would be about you. If you're male, female, or other, it doesn't matter. I can keep going and going and going and describing you as an entity. That student ID is the only thing that matters at the end of the day as far as creating a relational database. And I'll show you. Yes, I want to save that. And I want to create a new table. And I'm going to go back to my Home tab, and I'm going to change to Data View. And this one is going to be God. I'm trying to think about the easiest way to do this. I should have done sales. I'm going to do fees and do this where we have fee ID. Then what we're going to have is type of fee, and then you could do one of those things where you do a lookup wizard and you say extracurricular for like EC for extracurricular, and academic AC for academic. Doesn't matter, okay? And I'm just going to click finish, and I'll show you that it does work in a second. And then I could say amount, for instance, and I could set that as currency, and we'll leave it at that. Okay. And then because I'm giving each person, like you might have a fee, you might not have a fee, etc., etc., I can just put a student ID in here. I don't have to duplicate all of your information to throw a student ID on you. In Excel, I would have to put all your information linear and then show that ID or that fee at the end. I don't want to do that, right? And because that was an auto number and the other one we have to have the same data type, in programming I don't necessarily have to have that, because I can take your ID number from text and turn it into an integer. It doesn't matter. Okay. And I'm going to close that and say yes. Now here's the thing. I go to Database Tools. I go to Relationships. I grab these little buggers right here, pull them out here, and here's where the rubber hits the road. I drag student ID to student ID. I enforce referential integrity. I cannot give a fee to a student that does not exist. Okay? That's what enforcing referential integrity does. That is what would prevent you, as my employee, from selling something to someone that doesn't exist just so you can get a commission. Make sense? And I check these even though I never know why. I just do it. In SQL, you don't have that. You just kind of keep going. So now, want to see that in action? I knew you did. I'm going to create a form for student. And I'm just going to do it like this. So we've got Dave. Yeah. Did I click something I shouldn't have clicked? Oh, I'm not in the right view. Form view, sorry. Don't laugh at me, that's not nice. And then I'm not giving you my real address. You thought maybe. Now watch this. If I put it lowercase and I click down, remember I said I wanted it uppercase, so I can control how the consistency of how it looks. It can still be stored as a lowercase, doesn't matter. It can be input as a lowercase, it doesn't matter through a program. It's always going to show it as uppercase in reports out of this database. Okay? Now here, 48640, 1, 2, 3, 4. See how it's doing this for me? Okay? And I didn't add phone number. I should have added phone number. My point was that you're keeping it. I thought I did add. No, I didn't add phone number. The actual phone number you want to keep separate from area code because it makes it easier to filter and analyze data. Because now I can do it by area code instead of trying to do it and I have to pull area code off of the phone number based on parsing of data in programming, which you do not want to learn.
No, if you went back and added it, would it show up now?
What?
If you added the phone number? Would
Yeah.
it show up in the form?
Well, no, I have to add it to the form. Good question. But it's editable, so I can add it to the form if I needed to. And then the type. Remember I said I control how people get it? Now, if there's more than one charge, okay? Makes sense? So from this point forward, every time I want to add a charge to David Sanford, I just go out there, find David Sanford, which, by the way, I can just scroll through my records and find them. Okay. So if I wanted to, I could do Ethan and then or a 640, and it doesn't matter, and then 989, and then I could add it for him. Now I want to show you what's happening because of the relationship. Okay, I'm going to close this. I'm saving the form. It doesn't really matter. I can go back in and I can do that. I can open that form back up and keep entering data. So it gives me that the visual representation that makes it easier to input data for your end user, right? But if I go to student, it shows me all my students. If I click the plus sign, I see all related records for that student. That is a relational database in its dumbed down form. That is normalization in its simplest form. That's all we need to know. Okay. What I drew up there is an entity relationship diagram in its simplest form. The real entity relationship diagrams usually show the data type, and they show, which this program doesn't give you, they'll show the data type, and they will show like the data size, and then you might even have an example of the data for each field. Okay. To give you an example, I could take us out here and say entity relationship diagram. And I go to images. There are different ways that people go about them. This is the simplest form. Once you get out here, you start seeing what I'm showing you here. Whatever. Probably just gave this whole school a virus. But it's showing the data, or the field name, which, by the way, I should have said that too. That attributes, another name for that is field. Entities, another name for that is a table. Okay? So at the end of the day, you can look at this and you can look at it like this, and we can get all the way to the point that I'm about to draw something on the board for whoever's watching this video, but I'll say what it is. So off to the right, facing the screen, there might be another where it actually shows what it would look like. It would give an example of what your rules allow. You know, because the other thing that we end up looking at are data specification rules, and literally every field in every table gets a data specification form, and it becomes part of the data dictionary. And most organizations do not have these, and you really should. Anytime you're creating a piece of software, that person that's creating the software should have an ERD if it's database related, because you need that to create the program. So you know what fields are what form and various things like that. So ERDs are very important. But you get the idea that I just took us through all of that just with 2 tables. This is multiple. If I created that, this is the same concept, right? We're dealing with professor, student, class, and role. A class can have many students enrolled, right? So your primary key is student ID and your primary key is class ID. What that is this combined key. I don't normally do those, just because I don't usually have a reason to, because I only create databases for software that I'm writing, so I already know how I'm doing it. But other people will do that. One class can have many enrollments, and every enrollment has the grade, right? So that's technically a student ends up with a grade, correct? A class ends up in here, so you can have a grade for each class that student takes. Class only shows up here once. By the way, that's what this means. One class can have an infinite number of grades. A grade cannot exist here if the class doesn't already exist. Okay? So there's that. One professor can teach an infinite number of classes. One course can be used for an infinite number of classes. So in this case, course might be MIS3250, but I offer it many times, right? I have multiple sections of it every semester, and I have multiple sections of it every year. So I have that course showing up once in this table, but I get to use it an infinite number of times in class, because class is where I add the section number in the year. Make sense? So one room can be used for multiple classes. Not bad. I can simplify anything that I choose just based off of, and here's the reason I simplify this. You don't need to know all this 100%. You need to know enough about it to understand why these databases that are used in, what gives ERP systems all the power, right? I can create reports. Let me go back to Access. And by the way, you don't just have Access. There are multiple different database programs out there, but primary one is SQL. Okay. This actually has SQL code in the background that's created through Microsoft Access. But if I wanted to, I can go back here and I can create a query. So I can ask specific information. So if I have, let's say I put student ID, first name, last name, and then I go here to fees, and I want to see the type of fee, the amount of fee. Okay? I don't need to see the ID necessarily. And I click next, and I click next, and I modify the design, I click finish, and right here under criteria, trying to remember, I think I say, yeah. I could do something like this, and when I run this query, oh, that's why. That's not what I put there. Do I have to have an equals? Oh, why can't I remember that? It's been so long since I've done this. Why can't I remember? Oh, I know why. That didn't work. It should have asked me. Do I have to do it that way? Bear with me, it's been a while since I've actually done this in Access. I'm trying to remember. Is it something like that? I'm gonna have to look it up, but you can make it where you ask for the input for the criteria, and I can't remember how to do that all of a sudden, but I could just do Dave is the criteria, put that in quotes of course, there, and when I run it, why? Oh, because I'm putting it in student ID. Ah. Trying to remember. This might work. Yeah, it doesn't like that. I'll have to look it up. Oh, I'm missing a quote. That's one reason. Yeah, that's not the right way. I'd have to go back and figure that one out. I don't remember why. I'm just off the top of my head. I can't seem to remember how to do that all of a sudden. But if I put Dave in here and I run it, did I put my name as Dave or David?
David.
No wonder. Thank you. Thanks for calling me out on that, people. Some people's kids.
Corrected.
Rule number 1, if I'm ever wrong, refer back to rule number 2 that I'm always right.
I thought rule number 1 was you're always right, then rule number 2 was if you're wrong.
What did I just say?
I've heard that 1,000 times.
What did I ever say? What did I just say? Tell me. Don't say it. Anyway, see, I can see just the records for Dave Sanford. Oh, I know. Okay, I just remembered. It is this. I believe that is it. Okay, see, so I can do this and I can say, what was the other name I used?
Ethan?
Ethan, thank you. So I can show just the records for Ethan, so it does prompt me, say, hey, enter this information. Now the thing is I can create a form off of that query. Yes, I want to save that there. So now all of a sudden, you know, I can view it in a different format, and I should be able to type in, why is it not doing that? It should have done that. Let me close it. Yes, I want to save it. That's fine. Now let me go to the form this way. Let's go to this query. And there. Now when I go to open the form, it asks me for the name. So right away, if I type David in here, it's going to pull up David's form, show everything related to David. Okay? So there's power in this, and it's really easily shown because we can do it with just a few fields and a couple tables, and we can make use of it. The other thing about that is I can create a report, and I can create it off of this query, for instance, and I can say create, and I want report, and it says enter first name. I want a report for David. Hit OK, and it will give me a written or printed report of everything related to David.